Learning a series episode 2, and today we are going to learn about borrowing. To understand borrowing, let's assume a simple analogy where your friend borrows a book from you. He can read that book but cannot edit it because you still hold the ownership. Not only your friend, but there can be multiple friends of yours who can borrow the book, read it, and then return it back to you because you still hold the ownership. Rust also follows the same analogy in its structure. It says that there can be multiple immutable borrows at the same time, but there will be only one mutable borrow at a time, and they cannot exist together. Now let's see that code in action. Now here, as you can see on your screen, this is my main function and I have created a string variable called neo. The variable name is name. Rust here is not complaining about having multiple immutable borrows like ref1, ref2, ref3, ref4. It's totally fine because they are not going to mutate my name variable. So in Rust, owning the data means you can mutate the data and you can do anything to a data, and at the end it goes out of scope. Now let's see how it behaves in a mutable borrow. Here you can see I have done the same thing, but this time I am having a mutable borrow of the variable name, and it is being stored in the variable editor. The mute keyword indicates that it's a mutable borrow, and now I have some exclusive access on the variable name, and I can just push the string slice onto the string neo, right? This is the mutable borrow of that variable, and all the above things that you have seen are immutable borrows. Now let's see if they can both exist together. Now here you can see we just have these two things at the same time. I have a mutable borrow called ref1, and I have also a mutable borrow that is called an editor, and they cannot exist at the same time. As you can see, a warning over here, cannot borrow name as mutable because it is also borrowed as immutable. Now these are the borrowing rules, as you can see, that are applied by Rust even before running at the compile time. And why does this exist? It simply exists to save you from the data races condition at the runtime. So Rust makes sure that your program compiles correctly and does not throw any data races or memory leaks in runtime. Follow me for more and comment borrow if you get it, and also comment borrow if you want the docs to read about it online. See you in the next one.